Hello Westline, this is Mr. Themes coming at you. Today we're going to be looking at lesson 15.2, indirect measurements. You will need a calculator for this lesson here today. Make sure you have your pencil, make sure you have your paper out in front of you, and follow along very carefully with my notes. First thing I want to do is mark up the learning targets for our lesson today. The two learning targets that we're going to be working on is number one, we're going to apply the properties of similar figures to determine missing lengths of those similar figures. So make sure you go ahead and mark that first learning target up. And then the second learning target is we're going to be solving problems using similar figures. So looking at your guided notes here today, we're going to do this first one on the left-hand side together, and then I'm going to ask you to press pause and do the one on the right on your own. So the corresponding sides of similar figures are proportional and form a common ratio. This relationship can be used to find the missing length. So if we know that these two figures, and this is trapezoid QRST, is similar, this symbol right here means similar, is similar to the other trapezoid EFGH. What we're going to do is we're going to write the ratios of the corresponding sides from the similar triangles in the trapezoids below. So first of all, let's look at this first similar figure here. The first corresponding side is this side QT. If you look at the other bigger trapezoid, that's going to correspond to the side EH. So we'll write in our notes, we'll go QT over, this is a ratio, over EH. And we know the side lengths of those two. The small is 35 over 50. So that's the first one. Another corresponding side that we see here is the side QR, and that corresponds to EF. So we'll write that one QR over EF. And what you notice about this is you will see that only one of the trapezoids actually has a side length. So we'll put 21 over, this is a question mark, but we'll use X because we don't know what that side length is. So that's two of the sides there. Then we have RS. This trapezoid here corresponds to the larger side trapezoid over there. So this one is RS over FG. We don't know what RS is, so we'll put that one as X this time, but we know that the larger trapezoid has a side length of 70. All right, and then finally, TS corresponds to F or HG. I ran out of room here, but you can do TS over HG. And then we know that that's going to be X over 80. So what you'll see on all of these is I put the big triangle, or sorry, the big trapezoid. Hold on. I put the little trapezoid on top. So little or the small trapezoid in the numerator every time, and then in the denominator I put the big trapezoid. So you want to keep that consistent every time that you match up corresponding sides. So the big is in the denominator and the little is in the numerator for all of these. Little, big, little, big. And then finally, the ratio that we're going to find here is if we reduce, the only one we can look at really is 35 over 50. So if we're going to reduce that, we reduce that down. Well, 5 goes into both of these. Let's see, 5 goes into 35 7 times, and 5 goes into 50 10 times. So the common ratio that we have between these similar trapezoids is 7/10 is that common ratio. I would like for you to press pause right now, and I want you to do the same thing we did for the trapezoids for these two triangles. Write the corresponding sides. Notice that you'll be able to correspond two of them, and then find the simplified ratio down. Press pause now and do that one on your own. Okay, let's take a look at these next ones. So we're going to do the same similar thing here. We want to find the common ratio of these two similar quadrilaterals. So for the common, it says what is the common ratio of side AD to WZ. So here's AD and WZ. So if we know, let's see, AD over WZ. So AD is 15, it's the bigger trapezoid, and over the smaller trapezoid is over 6. If we're going to reduce that down, let's see, 3 can go into both of those. So if we divide these both by 3, let's see, we get 3 goes into 15, 3, 6, 9, 12, 5 times. and 3 goes into 6 2 times. So the common ratio would be 5/2. Now we can use this information to find the length of segment WX. WX would be this length right here. If we know that this is the ratio between the two quadrilaterals, so we can either use 15/6 or 5/2, either one would work. I'll use the easier one, 5/2. So if we know that 5/2, that ratio is going to be equal to this corresponding side here, so that would be 25/x. We don't know what this is. This is x here. We don't know. But we can solve this proportion now. So whenever we're solving proportions, what we would do is we would cross multiply and divide. You guys know how to solve a proportion. So then that's going to be 5x, and I want you to write all of this work. 5x is equal to the other proportion, which is 2 times 25. So I'll write all this work, 2, and I'll put parentheses 25. Showing all my work, I'm going to rewrite this, so now it's 5x is equal to 50. To solve for x, you divide both sides by 5, and you should get your value of x. X is equal to 50 divided by 5. X is equal to 10. So that is the length of segment WZ right here. This would be 10. If you look at this, that looks like a good relationship. That seems like a reasonable answer. X is 10. I want you to go ahead and press pause now and do 3A and 3B on your own. Press pause and do that. For number 4, now we're given two similar triangles. They're telling us that these two triangles are similar here. So again, if we can find the corresponding sides, we know that this height is going to correspond to this height here. There's the small triangle, and then the small triangle x, we don't know that, is going to correspond to this bigger triangle over here. So to set this up, we'll put the small triangle over the big triangle, and there's a lot of different ways you can set this type of problem up, but I'll go ahead and for ours do 2/5, because 2 and 5 correspond, and that's going to be equal to the other side of x/7. Now notice it says round to the nearest tenth, so we need to set this up and solve. So it's going to be, let's see, cross multiply and divide this proportion again. And we get 5x is equal to 2 times 7, because that is the other cross product there. So solving this proportion, we get 5x is equal to 14. To solve it, we would have to divide both sides by 5 here. And this is where you would probably want to use your calculator here. And if you solve this, you would get x is equal to 2.8 feet. So make sure you write that on the blank given. Make sure you put your units, 2.8 feet. And I always like to circle that final answer. If we plug this back in here, it makes sense, because if this side is longer than our height, the 7 is more than 5, then this hypotenuse has to be greater than the height as well. So that makes sense. Press pause and do number 5 on your own, setting up the same proportion. Notice this is flipped around though, so be careful. Press pause and do number 5 right now. All right, for number 6, same type of situation here. We have two similar triangles. We need to round our answer to the nearest tenth. We can match up the corresponding sides. This h, is going to equal to this. Notice that this is the bigger triangle, and then this length is going to correspond to there. So when we're setting up this proportion, we would get h/32, and that's going to be equal to 103 over to 34.5. Now this one's going to take a little bit of extra work here. We definitely going to need a calculator for this. When we do our cross products again, and to solve this proportion, we would get 34.5 times h is going to equal to 103 times 32. So showing all my work, make sure you're writing all this work down. You get 34.5h is equal to 103 times 32. Let's see, that's 3,296. I use my calculator for that. To get the h by itself, we would divide both sides by 34.5. Divide this side by 34.5. Remember, there's always a balance line that goes through these, so there's really like a balance line that goes right in the middle. And then we can get h is equal to, when we divide 3,296 divided by 34.5, we should get 95 and a half. And that would be our answer. Whoops, 95 and a half. I'll write my answer in purple here. 95.5. Go ahead and press pause now for number 6 and do number 7 for those similar rectangles and solve your proportion, setting up and solve for x. Press pause and do that now. All right, last one here. So here we have indirect measurement. What you'll notice in this picture is we have a flagpole. And sometimes we can use similar relationships to be able to solve for some object that is really big. So let's imagine that the sun is over here. This is the sun. And the sun is hitting our flagpole, and then we have this ruler that's a little bit smaller. The ruler is only 3 feet, but we don't know how tall this flagpole is. But the sun is up here, and it's casting a shadow that is 8 feet long. Okay, and then when we set up a ruler, which is 3 feet high, we know that the ruler is 3 feet high, that casts a shadow that is 2 feet long. So this is a similar relationship. This is called indirect measurement. We're indirectly going to be measuring the height of this really tall flagpole using the shadows that are cast. So if you notice, look what we have. We have similar triangles here. We can set up another proportion to solve for the height of the flagpole. Without directly measuring it, we're going to be able to solve for the height. So let's find the corresponding sides. So x corresponds with the height of the ruler. That would be x over 3 is going to be equal to 8 over 2. So we have our proportion set up. Let's go ahead and set up and solve this. So let's see. Cross products, 2 and x is going to be the same as 8 times 9. So I'm going to set this up. So 2x is going to be equal to 8 times 3. So 2x, 8 times 3 is 24. Oh, we don't need a calculator for this. We divide both sides by 2. Divide both sides by 2. And we should get x is equal to 12. And this would be 12 feet here. So let's make sure we put our labels and then circle that final answer. So the height of this flagpole is actually 12 feet. We found that just by using the relationship that we have between the ruler and the flagpole. Make sure you have all of this work down and all the work from all your other notes. All that work should be down. And right now I want you to do the last one, number 9, on your own by using the similar figures relationship to set up and solve problems for number 9. Thank you so much for following along. Press pause and complete all the rest of this work on your own.